Well, it's time for our first video. So, for this first video, what we're going to have is a review of basic skills. Everything you've learned from Algebra 1. Just trying to remind you what these basic things are, so that way when we get started, you'll know it. So, adding and subtracting like terms, multiplying terms, applying the distributive property. All things you went over lots in Algebra 1. So, like terms have identical variables, those variables to the same exponents. So here I have a list of just general terms. We'll go through and look. So the first term is just x. So look through our list. Who else just has a plain x? This is off. X, 6x, those are fine. This has an x and a y, so that's not. This is an x squared. Well, these terms are just plain x, so that doesn't work. xy, this has a square and a y. Those seem to be the only ones that have just plain x's. So we'll switch colors here. Next term is just a plain y. XY, that has an X. We're not looking for that. This has an XY again. This has an X squared and a Y squared. Whoa! That guy right down there. 8.7Y. Just a plain Y. Those are like. Do green. XY. There's a plain xy. The 7x squared y squared would not work because the two variables are being squared. We just want the two variables. Good there. Switch my color again. Let's see here. X squared. There's an x squared. Those two are alike. So is the 19x squared. All of those have an x. That x is being squared. That's it. Next like terms. Let's go purple. 7x squared y squared, negative 3x squared y squared. Both have x squareds, both have y squareds. They are alike. Negative 2 and 16z. Those are not like terms. They're completely different from each other. So, they're completely different from everything else on there, so they have nothing that matches. Now, the reason we care about like terms is because like terms can be added together. You just add the coefficients, the number in front. Like if we added the x and the 6x, we'd have 7 x's. We couldn't add the negative 2 to that, because it doesn't have any x's. I have some examples here. Switch over. There we go. These things we're going to work down. So the first one, 3 plus 7x plus 4x plus 2. Well, the x's are like 7 plus 4 is 11x. And the 3 and the 2 go together. Those simplify to 5. 11x plus 5. Cannot go any farther. You cannot get this to be 16x. You cannot add the terms that have x's with the terms that don't. The next one. We have some x squared terms. 6 plus 2 is 8. X squared. We have a term with an x. A term with a y. A term that doesn't have anything. 8x squared plus 2x plus 3y minus 4. You cannot add the x and the y together. Those are different things. You cannot add the x squared and the x together. Different things because of that exponent. The next page. Ooh, get all sorts of stuff here. Starting with an xy, we can add those together. 8xy Just the plain 5x, nothing else like it. Same with the 6y. Same with the xy squared. You cannot add those two terms together because the one has the y being squared that makes it different. Now we switch here to multiplying. Multiplying does not care about like terms. You can multiply together any two things you want. X times x, well, that's represented with the exponent, x squared. 4x times 3x. 4 times 3 is 12. X times x is x squared, 12x squared. Multiplying again, just using the parentheses. 2 times 5 is 10. We'll have 1x being multiplied there, so it's just 10x. Another example. 3 times 7, 21. We just have the 1x. We have a y times a y. So the y's get squared. Now notice, think of your order of operations. Only the y is being squared here, not the x, not the 21, just the y. Another multiplication problem. Negative 2 times 8, negative 16. X squared times x would be x to the third power. Y times y squared is y to the third power. Hopefully these examples are looking familiar. I'm sure Mrs. Bird had you do lots of them in Algebra 1. Lastly, the distributive property. I'm sure you had to do lots of these in Algebra 1. That's why we're only going over these fairly quickly. You're multiplying this 4 to the entire the entire expression inside the parentheses. So everything inside the parentheses needs to get multiplied by that 4. So 4 times x is 4x. Add or multiply the 4 to the y also. 4x plus 4y. 8 times the 2x is 16x. Minus 8 times 4 is 32. Hopefully this looks familiar. A couple more pages of examples. In the parentheses, it's always a good idea to look to see if anything can be added together. Look for our like terms. X squared, x, just regular 5. Nothing can be simplified, so it's just a matter of multiplying. 6 times 9. 6 times 2. And 6 times the 5. You have to multiply the 6 to everything. Now we got two what are called binomials being multiplied together. You may have been taught it first, outer, inner, last. First, outer, inner, last. But it's really just the distribution property again. You have to multiply everything in the x plus 2 parentheses to everything in those parentheses. So, x times x, x squared. The x times the negative 3, because the minus sign. Now you need to multiply the 2 to everything in the parentheses. The 2 times the x. And the 2 times the minus 3. Now we need to look, see if there are any like terms. Yes. Negative 3x plus 2x is minus x. X squared minus x minus 6. One more example. It's a little longer. This is why I don't like using, This is why I don't like using FOIL as much. Is just remembering it is the distributive property. Because that whole outer, inner, last thing doesn't work quite that well with this. We need to take the x times all of that. X times x squared is x cubed. X times 3x is 3x squared. x times negative 4, negative 4x. Now, take the negative 1, don't forget about your negative, times everything inside those parentheses. Negative 1 times x squared is negative x squared. Negative 1 times 3x is negative 3x. Negative 1 times negative 4 is plus 4. Add our like terms. X cubed plus 2x, don't forget you're subtracting there. Negative 4x minus 3x, negative 7x plus 4. There you go. So, hopefully, those examples kind of reminded you of things you may not have seen for a year or two. Hopefully you did them in geometry last year. Regardless, hopefully got you thinking about that stuff. And we'll see you in class tomorrow doing exercises on the same stuff. Alright, thank you.